Hi everyone, my name is Johan Stokking. I am tech lead and co-founder of the Things Network. I'm very happy to be back. Thanks Fintan and James for the invitation. Last year I was here, I talked about the Things Network, how we started, look back in history. This year I'd like to look a bit in the future and really look at the challenges in scaling the Internet of Things. Because we've been hearing from Gartner the predictions that there will be billions of devices. So this year, for example, they expect about 8.5 billion devices. Next year it's going to be a bit more than 10 billion, and then in 3 years from now expected to be around 20 billion devices. So this is a lot of devices, a lot of endpoints. And what's very interesting is the differences in the segments. So we have for example, the consumer segment, where you have smart TVs, set-top boxes, smart thermostats, and then we have business use cases, so cross-industry, very generic devices like lighting, security systems, and then we have the vertical-specific business use cases. And these are three different segments, and they have different ways of market development and also different price points. So for example, the price development, you see that for consumer and cross-industry business devices, they are quite constant in terms of projected cost. So this is the hardware spending per unit. So this is not even considering the IoT services around it. And Gartner says that the vertical specific devices, they will decrease in endpoint cost. And this is probably because there will be a lot more low cost and high volume devices on the market. And that is what we are particularly interested in. So this is the cost. And then, as we discussed also yesterday with, in a number of other presentations, it's very interesting also to look at the value. So how much what is the value of these devices? And there are many use cases out there where you can actually ask yourself, hey, what is the value that this really brings? Well, we all know the term Internet of Shit. We have different use cases. You know, why would you need a clock, for example, with an IP connection if it just displays the time? You know, it can only go wrong, waiting for an IP address. And the reason why the industry is connecting these devices is because the cost of connecting a device, of adding Bluetooth Low Energy, for example, to the bill of materials is $1 or $2. It's very cheap to make a device connected, but the perceived value for the consumer is much higher than that. So companies, they keep adding connectivity to devices without actually thinking, hey, is this actually valuable? What's very interesting in cost is the relation to scale, and this is what we've been seeing. This is basically on our own experience. There's no scientific background for this image. Is the relation between cost and scale, and we are now here. We have a high cost and high cost devices and low volume deployments. And as Jodit also pointed out yesterday, this is fine. This is also the time to learn and to see if things work. And when the cost of the devices go down, we get more scale, and this is the economies of scale, of course. And what's really interesting here is that if the total cost of ownership decreases, then we get a lot more new use cases that become available and that become viable. Very funny example is, for example, that if you have a parking solution in Southeast Asia, you can make a cost offering and value proposition and everything, but it's still cheaper to have people on the street counting cars than having a solution out there connected with sensors in the street. And that is a point that's going to change in the coming years. So yeah, total cost of ownership, a lot of different factors. We are, as the Things Network, mostly interested in connectivity. And connectivity is in IoT, we have different flavors. So also on a very high level, we have here a near-field communication that's being used primarily for tagging or for commissioning, contactless payments. Bluetooth Low Energy, super popular. Private personal area networks, so wearables. Wi-Fi is very usable for smart home and smart office solutions. And then we have an interesting category of long range and low bandwidth protocols. And well, first we have narrowband IoT, which is more like an offering will be provided by traditional carriers, uses the licensed spectrum, and it's going to be a bit more expensive, a bit more complex than LoRa, for example. A bit higher power consumption, but it's very useful for example, smart grids, high-value object tracking, connected cars. Then we have LoRa, and that is what we are particularly interested in. And LoRa allows for a lot of use cases, as it uses the unlicensed spectrum. So everybody can set up a network like this. We have use cases in agriculture, lighting, low-value object tracking, smart metering, utilities, maintenance, everything that has power constraints, basically. So even smart buildings, you don't even need to benefit from the range. It can also be just the ease of deployment or the fact that you don't need to change the battery every so often. That makes LoRa very useful. And what we often see is a combination of these. So many devices have 2 bands or 3 bands even. So you can have, for example, a LoRa device that uses LoRa as its main communication channel. But if it needs to send a lot of data, you can provision Wi-Fi credentials over a LoRa downlink, and so it connects to the Wi-Fi access point, sends a lot of data, and then shuts off the Wi-Fi chip again, for example. That's what we see quite often. Oh yeah, we have Sigfox, but yeah, we discussed that. Gary had a very good talk about Sigfox yesterday. I'm not going to repeat that. So LoRa uses the unlicensed spectrum. Everybody can set up a LoRa network. And so 2.5 years ago, Wink and I saw this technology, my co-founder, and we basically started the Things Network with this mission to build a decentralized, open, and crowdsourced Internet of Things data network that's owned and operated by its users. And this means that we build a network server. It's the implementation of LoRaWAN. And we make that available for the community, and we allow them to connect their gateways to the public community network. So the community builds one big network together, and it's open. So you set up a gateway for yourself, for your own coverage, but at the same time you also allow others to make use of your coverage. So it's crowdsourced in that sense. Gateways are not ours, but it's owned by the community, and it's also operated by its users. And since we started 2.5 years ago, we now have 512 communities around the world in 94 countries. And what the communities do is basically they are initiated by somebody in that city or area that has connections with the government, with businesses, with educational institutes. Maybe he or she runs the IoT meetup in the city. And they organize meetups, they talk their own language, they know the challenges in the city or area, and that works out really well. Yeah, 94 countries, that's also a lot. LoRa, you can set up a LoRa network almost everywhere using the ISM bands. More than 23,000 members, more than 1,400 gateways connected. We are shipping our Kickstarter gateways in November, and then we have, I think, about 2,000 more gateways connected to our network, so that's going to really grow the network. And one of the communities is Things Network Amersfoort. That's a Dutch city, and there are a few guys in that community that are very interested in the range and in helium balloons. It's kind of a hobby. It's also quite serious, and they made a helium balloon, and it ascended in about 3 hours to 38 kilometers. And it had a LoRa sensor with GPS and a few other sensors, and it kept sending messages. In 3 hours, it ascended to 38 kilometers, and it reached a gateway, so from here all the way to Poland, more than 700 kilometers away. And this is only using 25 milliwatts of transmission power. So this is how far LoRa modulation can go in ideal circumstances. This is not a practical case unless you really want to go that high, maybe on airplanes or helium balloons, or even turn it around with satellite communication. So that's really interesting. And the reason why LoRa doesn't work with these ranges in cities is because of the obstruction of buildings. And that is why you can cover a city with tens or hundreds of gateways, and you don't need those telecom operated towers to deploy a LoRa network. So that's basically what we do. So let's look a bit at the developer ecosystem, because that is really the first challenge. And if you have an idea and you want to build your first prototype, so the 0 to 1, there are plenty of tools and developer tools and languages available to get you started. So you have Node.js, Raspberry Pi, Wi-Fi connected, Node-RED, and you can easily build a sensor, for example, to monitor the availability of meeting rooms. And this is also what Marissa is going to present. She did it for her graduation project, so I'm going to let her do the introduction, and then I'll go back and talk a bit more about scaling and going after this.
Okay, thank you, Johan. Hi, I'm Marissa. I just finished my conversion master in computer science at UCL, and as my final project, I built a IoT application that transmits air quality and sensor and temperature sensor data to a mobile app using the TTN's LoRaWAN backend. And this is the node that I created. It uses a CR40 cradle board as a hub. The air quality sensor is the little green thing on the bottom, and the thing with the antenna is the LoRa transceiver. And that transceiver sends the data to the TTN's network and network server via the LoRaWAN infrastructure. And this looks like this. So on the left-hand side, we have some at the time, some metadata, some status of the network or the gateway, and these are the names of the nodes. So I have two, one for the air quality, one for the temperature, and this is the actual payload with the temperature or the air quality. This then gets forwarded to a platform called Cayenne from my devices via a integration from the TTN side. So this is the app. So on the bottom you can see again the temperature. On the top is the air quality with a ppm value and some things about the signal strength. So this is my project in a nutshell. And what was really great for me with the TTN was that it allowed me to get really quickly up and running. Like they had really great documentation, but especially their free LoRaWAN service tier, as well as a third-party integration with the Cayenne, with the mobile app. I didn't need to worry about any backend or database. It was just all there. I could just use it for me to prototype, and that was really great. On top, they have this really great community of enthusiasts. There was this complete stranger who I connected with via the TTN London community. He lent me his gateway to do these test runs. I had a million questions from my report, put on a Slack channel, got instantly answers, even from Johan. So I think they really created this great ecosystem for IoT developers. So thank you, Johan, for that.
Thanks for the plug. All right, so thank you very much. Okay. So that is really a good example of 0 to 1. I didn't know Marissa before yesterday, so that's really how TTN works. I'm myself also amazed by how easy it is to set up. But again, that is the 0 to 1, and I think this is a solved problem. The next is also kind of easy and accessible for everyone, which is your first batch. You have Arduino devices, you can already start using LoRa quite easily, and then your solution looks a bit more like this. So you have a developer board which costs maybe in high volume like 20 or 30 euro battery, and you have maybe an off-the-shelf case around it, and that's very easy to deploy your first solution. And when it gets really interesting is when you scale from here, so the next steps. And today, this is basically the reality. You need embedded C programming. Maybe you need even to know a bit about assembly for optimizations. You have custom PCB design. You're dealing with a real-time operating system on the embedded device, and this is far outside the comfort zone of most developers. And because this is the comfort zone of where most developers are in today. They are used to JavaScript in the browser, then there was Node.js to run JavaScript on the server, then you have Heroku, which is a web platform where you can easily deploy your web applications to. But this is really where the magic happens, where on large-scale devices, what you need to be capable of. So I think what needs to happen in the coming years is that these zones come together, and this is probably here to stay, but we can really work on making the comfort zone bigger for application developers, and I think that's important because if you have 20 or 40 or even 80 billion connected devices, there are not enough embedded firmware engineers to build those. We need to make embedded device development accessible and for developers that are coming from the web or from the cloud background. So we have different things, a lot of development going on here. We have Rust and Go, Rust, for example, running on embedded devices already. There's JerryScript, which is a JavaScript VM that works on microcontrollers. There are integrations, IoT platforms by AWS and Azure. And we, with the Things Network, we really try to be right there to connect the embedded devices, large-scale solutions with the rest and to build integrations. And I was looking at the sponsor list, and for example, we have an integration with IBM Watson IoT. We run our public community network on Microsoft Azure, and we have an integration with Azure IoT Hub. We have an integration with Salesforce. We have people managing gateways with Resin. We have an integration with Open Sensors. I don't know what Confluent does, but they sponsor the coffee, and coffee is great. So, yeah, okay, all right. So yeah, and then another challenge in scaling is what is not very discussed currently is really the environmental impact. Because if those prices go down, and if you have devices that cost only a few dollars, then you have the throwaway price point. Then after you use it, you just throw it away. And that's going to be very bad for the environment. And this is going to be more of a problem because the prices will go down, but also because those devices will be more integrated and harder to disassemble. So this is a nice stack of PCBs, but with so many IoT devices, it's really hard to disassemble lithium and PCBs and casing and plastics and everything. So one of the challenges is, can we extend the lifetime of devices? And we can do that by, for example, a secure transfer of ownership. If you move to a new house that is full of sensors, for example, can you transfer the ownership of those devices without removing them and throwing them away, for example? Another thing is firmware updates to extend the lifetime, to add, for example, new functionality, to patch security issues, maybe to specialize them so you have the same physical device, but it can do different things with different firmwares, for example, much like an iPhone with an app store. We can also bring that to embedded devices. Yeah, so firmware updates, for example, we did a demonstration in the LoRa Alliance together with ARM and Multitech of a firmware update where you have a user interface where you can select which devices you want to update. And the reason why this is so challenging is because those LP1 devices, they are in deep sleep 99% of the time, and you still want to send an update to them over a protocol that is very bandwidth constrained. So you need to have a device selection, you need to make sure that they wake up from deep sleep at the same time. You need a multicast session so you can address them all at the same time. You need cryptographic verification. There's always packet loss in LoRaWAN, so you need forward error correction so that devices can correct for lost packets. And these are challenges that we are working on within the Things Network together with the LoRa Alliance to make the wide adoption of LoRaWAN more available. And then we have a few general things. For example, can we change business processes? The smart mousetrap, we have thousands of these on our network. The funny thing about this is not that it's a smart mousetrap, but also that it really changes the whole business process behind it. So with the traditional mousetrap, you have to go to this mousetrap every day to see if there's a mouse in there. With this mousetrap, it sends you a message. So it's a complete change from pull or from polling business processes to push and notification based. This is a very simple example, but this will be there. This is applicable to many business processes. Another thing is we are used to human error. That is, we accept that as a society. But will we accept computer error? And when will we accept that? Is it going to take a few generations even? When we rely on devices making decisions for us that also affect our safety, such as self-driving cars. And this is also something that may stop or influence the mass deployments of IoT. Also, currently, LoRaWAN, we have about a dozen serious LoRaWAN networks, and they are not interconnected today. And the internet, for example, consists of about 55,000 different networks that are connected with peering and transit. And this is something that we also need within the LoRa Alliance to work on, so that we connect all those networks and it becomes one big network, so that it doesn't really matter whose gateway covered you or your use case, but it's handled just upstream and your data just arrive and it's connected and all integrated to your digital twin in some IoT platform, for example. And we are not there yet also. So yeah, what we have, of course, the bananas, but I'm first going to talk about the privacy issues. Of course, you have screens with cameras that do face recognition to see how long you look, how old you are. What is the next step? Are they streaming video to the cloud? With tracking devices, they are going to cost like a few dollars, and it's going to be very cheap to track anyone. Just put it under somebody's car or in a handbag. And these are also issues that, that we will have when we see mass deployment. So yeah, bananas. I brought 2 bananas, and I'm going to ask you what the difference is between this banana and this banana. The only difference is, I will answer it for you. It's 2 days. So this banana I bought 2 days ago. This banana I got it here from here, just right next door. And but they are harvested 3 to 4 weeks ago. And you can sell them only like this in a shop. Bananas are very delicate products. And the reason why I talk about this is because it's a great use case for IoT, but also because my family business is for a few generations in bananas, not anymore. I prefer software. But this is my grandfather with some bananas in 1939, one of the rare color pictures at the time. Anyway, when bananas get harvested, they are green like this. So they are not ripe, but the harvestation process is also very important. The time that the banana is just mature enough to harvest, but not ripe enough for transportation. Transportation goes in these ships in special containers, and the chain is completely regulated. So the time between harvestation and consumption is 3 to 4 weeks. It's a very delicate product. You have bruises and ripening process, which you can regulate with only changing the temperature a few degrees up or down, and you can add or remove ethylene gas. So that is how it goes today. And what would be very nice and a very good use case for big LoRa and private Things Network deployments is to make this whole chain connected. So to have on the farm coverage, on the ship, a gateway with, for example, a satellite backhaul. In the transport, you can have a gateway on a truck, a mobile gateway, in the store, in the shop. And this allows you to also, depending on, for example, market offer and demand, to control the temperature and the amount of ethylene gas throughout this whole chain, throughout the 3 or 4 weeks, even when, for example, the bananas are still in a container somewhere on the Atlantic. So these are use cases that we are facilitating with our network. We don't build this ourselves, but we work with industry partners to enable this. And these are really the large-scale deployments, and that is really what we see our role in. So it's really controlling that entire stack. So what we do as a Things Network community and how you can contribute is you can set up a gateway, and you can use it for yourself or for use cases that you just heard about, or for even commercial use cases. Our stack is open source, so you can find us on GitHub and get a network server up and running on your laptop, or contribute to our code or to our SDKs or documentation. We have a map of the communities where you can find communities around you and connect with people. There are events and meetups that are being organized, and we have labs where you can create a story, where you can share your product, but you can also learn from other open source products and verticals that are built on top of the Things Network. And this is just a map of some of the communities around London. So yeah, that's my presentation. So I'm happy to answer some questions.